The select statement. In this nugget, we introduce the SQL command that you're likely to use more than any other as a database administrator, and that is, no surprise, the select statement. But first though, I'm going to introduce you to one of the sample schemas that Oracle gives us as we learn Oracle Database. We're going to be working with the HR sample schema, and before I introduce you to HR specifically, we need to understand what the word schema means. We cover that in much greater detail in my CBT Nuggets course on DBA1, but it certainly bears some discussion here as well. Once we cover those bases, we'll then deep dive into the select statement, first examining its purpose, its syntax, where and how it's used with Oracle Database, and we'll give you several examples such that by the end of this nugget, you may not be yet a master of the select statement, but you'll certainly have the fundamentals down. Without any further ado, let's get started. About schemas. Oracle defines a schema as a logical container for data structures. Now, logical calls to mind the distinction between the notion of logical versus physical database constructs. Different IT technology vendors have different definitions here. In a very general sense, we could look at a network interface card and its MAC and IP addresses, if you're familiar with those. The media access control address is physically burned into the firmware of the card, and that would be considered a physical address for that network card. By contrast, that same network card can be bound to any IP address. The IP address, that is known as a logical address. With respect to Oracle Database, Oracle draws the distinction between logical structures and physical structures in terms of whether or not those structures are visible at the operating system and disk level. Therefore, objects like data files, control files, redo log files that physically exist on disk are physical database objects. Logical objects are things like table spaces, schemas, and ultimately your base objects like tables, views, etc. Schemas are helpful for a few reasons. The fact that they're a container means that a single schema name can be attached to many different objects, and almost guaranteed your Oracle database will be composed of more than one schema. Let me give you an example. If we didn't have schemas, then Joe user or Jane user could create a table, let's say, called emp, and work on that table all day long. However, what if another person, say Tim, log in using my Oracle account and I go to create a table called emp? Well, I'm not going to be allowed to do that, am I? Because there already exists an object with that name. Therefore, schemas present a layer of abstraction for your data structures, and they help avoid a problem called name collision, which is the example I just gave you, where you have an object with one name and you can't create another object with the same name. Check this out though. With the notion of schemas, a user named HR can create a table called emp, and Oracle will prepend the schema name to the object name. So the fully qualified name of the emp table is hr.emp. By contrast, I can log into Oracle using my Tim account and create a table with that very same name, but because its fully qualified name differs from hr.emp, these two tables would be allowed to coexist peacefully within a single Oracle database. Alright? So the notion of schema ownership is key. If you as an Oracle user have the ability to do DDL, namely create in particular, then that user account is often called a schema account. You'll find in Oracle literature that many people, Oracle DBAs and developers, use these terms synonymously, Oracle user and a schema. For instance, the HR schema that we're working with in this course has an associated owner account that comes to us by default out of the box with Oracle called HR. Therefore, the username and the schema name are always the same. But I tend to draw a little bit finer line between the user account and the schema, because certainly the vast majority of your users are not going to need or certainly should not be granted DDL ability in your database. Instead, they should be granted only bare minimum DML based on their access needs. For instance, you may have many users who do nothing but run selects against your database. Are those users considered schemas? You see what I'm saying? So I just want to make sure to give you that differentiation. As I mentioned, Oracle makes available several sample schemas, as they're called. There are a number of them. We're going to be focusing on the HR schema. This is a general purpose, fairly simple set of tables that will suit our needs just fine in this training course. You can obtain sample schemas a couple of different ways. When you run the Database Configuration Assistant in Oracle to create your first database, one of the options is to install the sample schemas. You'll absolutely want to do that in your development environment, in your practice environment, although for security reasons, there's no reason why you would want to install sample schemas in a production environment. This is just for learning purposes only. The other place you can get sample schemas is directly from the Oracle website. You can download them, download the documentation file that comes with it, and you can just run the scripts and create the objects, create the user, etc. So what you're looking at right now is what's called an Entity Relationship Diagram, or ERD. We talked about ERDs briefly in the first nugget of this course, and basically what you're seeing is the outlay of tables. Let's see, 1, 2, 3, 4, 5, 6, 7 tables that comprise the HR schema, and the notion here, HR stands for Human Resources. This sample database schema deals with, sure enough, employees and their information. You see that the anchor table here appears to be the employees table, and you'll see the name of the table and then each column within that table. Now, another thing that's nice about these sample schemas is that they not only give you the schema structure, that is to say the tables, but they also have already populated these tables with sample data. So we'll have grist for the mill, so to speak, as we continue our work. Now, you may be wondering what these little crow's feet connectors are between tables. This deals with the concept of the table relationship, where we're taking a matching field. Most of the time, for convenience, those field names will have the same exact name, but at base they have to have the same data type. And the notion of the relationship here is that we're able to avoid redundancy, needless redundancy, and separate our data out as granularly as possible. When you're mapping out an ERD for a relational database system, you always want to be thinking in terms of something called normalization. Normalization is the process of going through each table, looking field by field, and thinking to yourself, are we going to come across too much redundancy? For instance, you may take a first draft crack at the employees table and ask yourself, which attributes do we want to store for our employees? We'll need a unique identifier. We'll call that employee ID. That's fine. First name, last name, email. Well, what if originally you wanted a column in there called job? Well, that seems fine at first blush, but as you start doing data entry, you may have 25, 50 employees from the marketing department, another 25 in IT. You're going to have a lot of redundant information in that jobs column. That would be, in the principle of normalization, a good candidate to take your jobs out into a separate table, which is exactly what Oracle did here, and just track jobs specifically here, giving each job a unique identifier, giving the job a title, and then a salary range. The way we create the link between tables, and I'll actually show you how this works in SQL later in the course when we cover DDL, is that we can take the primary key or the unique identifier column in the source table and recreate that column in the destination table, applying what's called a foreign key constraint. So where the primary key exists in a related table, it becomes what's called a foreign key. Again, we'll talk more about constraints in a little while. So that is specifically the relationship that's shown in this example between employees and jobs. The crow's foot notation denotes what's called a one-to-many relationship. That is to say, the job ID field in the jobs table, every record or row in that table is going to be unique. You may have 20 job codes, and rest assured, every one of those is unique from any other job. So if we have job code 5, there will only be one and only one occurrence of that job in the source table. That's the one side of the relationship. By contrast, as I've already said, you might have 25 employees that match that job code in the employees table, so that job ID may appear many times in the employee table, hence the one-to-many relationship. So this ERD is worth studying, and we'll be referring to it several times as we proceed through the training. As I said in the opening of this nugget, select is going to be your most frequently used SQL command. Recall a purpose of the database, and the relational database in particular, an organized collection of information handled as a unit. We want data to be reliably stored, and we also want to make it as efficient as possible to pull data or retrieve data from that database. First, let me give you some technical buzzwords giving us the functions of the select statement. We have projection, selection, and joins. Now, what does that mean? Projection in this context means nothing more than using the select statement to retrieve one or more columns from one or more source tables. This is just the $5 word. Selection, I would put it as a $3 word, and refers to how we're pulling back rows. So we have the ability to take a source table, actually one or more source tables, and selectively retrieve a subset of rows or all rows, a subset of columns or all columns. That should come as common sense to you that that's what's going on. The concept of the join is very, very crucial and forms the foundation of the relational database management system. I just showed you a little bit about table relationships in the previous whiteboard, in which we looked at the HR schema and the employees and jobs table and the matching column that connects them. Well, we use a syntax in SQL called the join syntax to pull table columns, pull rows from one or more related tables. And it's really, as I said, what makes relational databases go round. That is to say, given the previous whiteboard, we could grab rows and grab columns from both the employees table and the jobs table. Why is that nice? Well, you'll remember the way the one-to-many relationship worked. Let me go back to the ERD for a moment. Our jobs table actually contains not the job ID only, but also the job title. If we were constrained to running selects against just a single table, and let's say we wanted to pull the employee ID, first name, last name, and we wanted the name of the job that each employee was attached to. Well, if our select statement were limited to just this table, the best we could get would be the job ID, which is probably a number and probably not very informative at all. You see what I mean? In order to drill into the jobs table and pull the title, we're going to have to use join syntax. And once we create that join, we can pull any columns we want from any related tables that are indicated in the select statement. Excellent way to do business, no doubt. I need you to understand that SQL statements are case insensitive. There are aspects of Oracle that are definitely case sensitive, and even more importantly, if we're working in a Unix environment, as you know, the Unix, Linux operating systems are historically case sensitive, whereas the Microsoft Windows operating system, just the opposite, historically case insensitive. But we can write our select statement with the keywords in all uppercase, as I'm showing here. We can use all lowercase, we can use sentence case. You can do whatever you want to, because SQL by default is case insensitive. However, you'll find in this training that I will try my hardest to be disciplined and make sure to capitalize my keywords and lowercase my table names and column names, just simply because that's the convention that we normally see in the literature, and I find it a little bit easier to read, quite honestly, when you make that distinction. The basic syntax of the select statement is as follows. We use select, and then there's some sequence here. This is going to determine what columns we're pulling from a table. If we say select star, select asterisk, select splat, as it's sometimes called, because I guess the asterisk reminds some early DBAs of a bug splattered on your windshield. Select star instructs Oracle to retrieve all columns and all rows. Basically, you'll run select star when you want everything from one or more tables. You can also provide a field list. Now, field and column, I'm going to use them as synonyms. Technically, you'll find in some literature a mild distinction, but for all intents and purposes, field and column are identical. They represent a discrete attribute that describes data in a single table. And note that we can just specify one column or a comma-separated list of multiple columns. Now, the order in which you list the columns is important only in as much as that will be the order that Oracle gives you your data back in. So if we wanted employee ID, first name, and last name to appear in that order in our query results, then that's going to need to be the column order that we specify in our select statement. We can use the optional distinct statement to pull just distinct occurrences from one or more columns. I'll give you a quick example. Let's say you have an employees table where you're storing their address, city, and state. Well, let's say in the state column you have employees from, say, 20-something different U.S. states. There'll probably be several from each state. You can use select distinct state to get back only the unique occurrences of, in this case, in this example, the state field. So distinct can be very helpful if you want to understand what is there in a table from a uniqueness perspective. Finally, expressions, which we'll be dealing with in depth later, allow you to do things like arithmetic, and you could take a salary column and multiply it by 12 to present a virtual column that gives an employee's annual salary, let's say. That's a simple example of an expression. That can really increase the effectiveness of your queries, being able to do that math on some of those columns. All right, so I think you've got half of the select statement down pat. The second half is, and this is crucial, you need the from keyword because Oracle needs to know which table or tables, potentially view or views, you're pulling the data from. And after the from, that's where it can get kind of complex when we get into joins. But for now, we're just going to be working with single tables. So we provide that single table name. Make sure to end the query with the statement terminator, with the semicolon, and you're off and running. This is the absolute bare bones representation of the select statement. In coming nuggets, we're going to learn to add more and more bling, as it were, to the select statement to make it much more powerful. As I mentioned, instead of, or in addition to actually, specifying one or more columns from a table in your select statement, you can do arithmetic on those columns. When you do that, you create what's called a virtual column. A column based on an expression doesn't exist in the base table, but it exists in the query results. And what's neat about Oracle is that you can actually take your select statement returns and pack that into a table if you want. You can export it as a flat file. You can do pretty much anything you want with those returns. All I want to say at this point about arithmetic operations is we have the traditional addition, subtraction, multiplication, and division. You can do higher order mathematics, but of course this stuff is the most common. The other point I want to make, and we're going to demo this momentarily, so don't worry about that, is that we need to keep in mind the order of operations precedence. You know, when I got into IT in 1997, one of my first colleagues helped me remember or memorize the order of operations. I'll never forget it. She gave me the mnemonic device, "Please excuse my dear Aunt Sally." You got it? So if you can think of something better to help you remember, go for it. But "Please excuse my dear Aunt Sally" helps me. In which the order of operations, and this is in fact an ordered list, top priority to lowest priority of what Oracle uses when it evaluates expressions. First, it'll look for parentheses, then it'll look for exponents, then it'll do multiplication, then division, then addition, and subtraction. Now this is not Mickey Mouse stuff here, friends. This is really important because you'll find if you're not using or keeping in mind order of operations precedence, you could very much, and very easily I should say, get back results that are inaccurate at the worst and not what you want at best. You see what I'm saying? I find that being explicit as possible in my SQL code is best because it leaves nothing to the imagination, it reduces confusion, it reduces ambiguity, and helps Oracle parse your query correctly, and also allows your colleagues, your fellow DBAs, and fellow Oracle developers to look at your code and get an easier grasp on what's going on. To that end, I'm a big fan of parentheses. If I'm doing anything besides simple arithmetic, I like to use parentheses to create logical components in my expressions, and I know those will be evaluated first before multiplication, division, addition, and subtraction, and again, in this order. Final keyword I want to show you before we dive into our demo is the description describe command. Describe is an SQL command used to describe or give us table structure. Very, very useful, especially if you're examining a schema that you don't own, that you haven't created. Maybe you're coming into a shop as an Oracle consultant. The first thing you'll want to do is run describe on those base tables to take a look at the column names, their nullability, their constraint situation, and their data type. We can use the full word describe, or we can just use truncation, desc. A lot of the Oracle commands actually do support truncation if you don't like to type extra characters. As I mentioned, you get the structure of the table, including the data type of each column. Quick nutshell review of data types if you're not familiar. When you build a table, you have one or more columns. Those columns all need to have a data type associated with them. Data type is going to determine the kind of data or type of data that's allowed in that column in that table. So immediately we can see data integrity coming to the forefront here. That is to say, if we have a salary column, we're probably going to be doing arithmetic on that column. So we don't want to choose a character-based data type there. We're going to want to use number. By contrast, you might be storing telephone numbers, social security numbers, credit card numbers. There, it doesn't make sense to use the number type, even though on its face you might think, well, a telephone number is all numbers. A credit card number is all numbers. That's true, but we're not performing math on those values. So we're going to have better bang for our buck by choosing a character-based data type. Oracle supports lots and lots of different data types, but in my experience, the 4 that you see here are going to comprise the vast majority of your table columns. Number, which you give the number as the data type keyword, and then you can provide in parentheses the precision and scale of that number. The precision is the total number of digits, and scale represents the number of digits to the right of the decimal point. So it looks like we've got number 3, 3 if we have a possible number range that looks like this, positive and negative. Varchar and char are our alphanumeric or character-based data types. You provide the limit or length of those fields in parentheses. The big difference between varchar and char is that char will always pad spaces. That is to say, if we create a column and assign it the char 10 data type, then even if we do some data entry and consume only 5 characters for that column, Oracle will pad out until we reach 10 characters. It'll pad spaces. So those column values always will be 10 characters long no matter what. Varchar, you specify a maximum length. Let's say you do a varchar 25. Even if you're storing, say, 12 characters, well, that's all that will be stored. Why is this important? Well, it's important when we think of disk space usage. We want to minimize slack space in our tables. We want to minimize dead and unused space. We want to use space basically as efficiently as possible. And another reason why we would want to make sure to choose a character-based data type for numeric values that don't support computation, like zip codes, telephone numbers, and credit cards, is that the disk space footprint for the number gets pretty darn high, especially as you increase the precision and scale. There's quite a bit of overhead to that data type. Finally, the date data type is exactly what you'd expect, used for date and timestamps. In this demonstration, I'm going to introduce you to the select statement in Oracle Database 11G. To that end, why don't we pop up Oracle SQL Developer? As you see, I'm logged in as the HR user, and let's get right to work. First of all, with regard to schema, we can run a query. Actually, it's a select. We can run the query select table name from user tables. User underscore tables is an example of what's called a data dictionary view. We're going to talk about data dictionary formally later in the course, but the importance of this particular select statement, we're grabbing, as you see, just one column from user underscore tables, is that user tables gives the currently logged on user all of their schema objects. HR is a user account that has DDL privileges, therefore it is a schema, and you see I've run the query and we have 7 schema objects. They're actually tables. I pulled table name from the user tables view. Now, how do we know that there's a column called table name in user tables? Remember, we can use describe, and we'll run that command. There's actually quite a few columns in the user tables view. Table name is just one of them. You see what I mean? A lot going on here. So I've found, and I'm sure you'll find as we go along, describe comes in really handy as a way of getting your sea legs with how particular schema objects are laid out. Remember I mentioned that SQL is case insensitive. SQL Developer has some really cool formatting tools built into it. A lot of them are accessible either through the menus or what I like is the context menu. That is to say, if we right-click the mouse, you get a tremendous amount of flexibility. Check this out. If we come all the way almost to the bottom and click Format, SQL Developer will capitalize our keywords. Let me do this for the describe line. It didn't want to do it, interestingly enough, for my describe line, but it gave me a nicely formatted select statement at any rate. Now, if I run this first select statement again, I've already shown you that the HR schema consists of 7 tables. We're going to be using all of these as we go through the training, but why don't we just start with the departments table. We'll run select star, which means all columns, all rows, from, and actually I'm going to pause here. Let me type M and space. Another thing that the Oracle SQL Developer environment gives us is this code complete option. You'll notice that as I've gotten to this point in my query, I typed the keyword from, and then as soon as I hit space, we got this drop-down list, and this is giving us all of the tables that we own in our schema. Isn't that helpful? And you can use the arrow key to arrow down or arrow up, or you could use the mouse to pick them out if you want to. I want departments, so I'm going to arrow down to departments and press enter. Very nice way to do business indeed. We don't get that in SQL+. And I do want to again give the disclaimer that I'm using Oracle SQL Developer both as a learning tool to help you learn the language and also because the output is so much easier to understand. But you need to spend just as much time in SQL+. We're going to be going into SQL+ in this demo in just a moment. So if we return all columns and all rows from departments, doesn't look like there's too many columns here. Department ID, which is the primary key, the unique identifier for each row, the department name, manager ID, and location ID. Now just looking at these column names, the fact that they're appended with ID lets me think that these are in all likelihood foreign keys that map to additional tables in the database schema. You see what I mean? And you'll notice also that there's no manager listed for several departments. And what happens there if there's no value, Oracle inserts what's called a null. Null isn't exactly a value. It evaluates to unknown, meaning Oracle can't say with any certainty that there's a value there. There's been nothing explicitly placed, but we certainly can't do any mathematics if there's nothing there. You see what I'm saying? Just to check it out, let's run a describe. I'm going to shorten that to desk. We'll run a describe on the departments table, and it just gives us the names, nullability, and data types that are used. Not as much information as I'd like to see. I'll show you how we can query the data dictionary to get constraint information later in the course. Simply because I want to practice my own preaching, let me open up a terminal session here, clear the screen. Let's log into SQL+ as HR, and I want to run a query from here just for the sake of it. Remember the edit command. The problem with edit is, as you just saw, if we haven't at least started a query, there's nothing to save. So we can't get to our gedit editor until we have at least something in the buffer. I'm going to start that something by just saying select employee ID from in the employees table. Now if I hit edit, assuming that I have the editor system variable set, I can modify my query as I want to in a nice graphical environment. And I'm going to expand this by bringing not just employee ID, but first name, last name, and salary from the employees table. Now again, you might be wondering, Tim, how do you know the names of these columns? Describe is your friend. You'll probably want to write out the description of tables to a file and keep those in a binder or even tacked up on your wall so you know what your column names are and your entity relationships among tables. Let's save our work, close out, and as you know, we can use the / to actually run the query, and it's given us our info. I'm going to get rid of the paging. I'm going to run set page size 0 to get rid of the paging, and we'll run the query again. And so this is nice. It gives us all 100 odd employees. It looks like close to 200, but you'll notice that the salary is just given in a straight number. I'm going to sprinkle in as we work different methods for increasing SQL+'s ability to give us better formatting. You'll remember the column command that we used earlier in order to shrink up column widths to display everything nicely in one screen. What we can also do is run column against a column and use the format keyword, and this time instead of A, where we specified the alphabetic width of a column, we can just use natural language in a sense to specify, in this case, a numeric currency format. I'm using a comma separator, dollar signs, and I want to see cents. So if I rerun the query, you'll see that the currency is much better looking, isn't it? Alrighty, let's clear our screen with host clear. Remember, I gave you the advice that you should probably spool off the descriptions of each of your tables. Now, if we type L for list, we can look at what's in our SQL buffer. Remember, it's this basic query against the employees table. If you want to spool the results of this query or any statement to an external file, you can use Logic tells you the spool SQL Plus command. Check this out. The way it works is you open up a spool by using the word spool and then providing a destination file name. I'm going to call this employees.txt. Press enter. Now we can, in this case, run the query, and to turn off spooling, just do a spool off. Cool. So why don't I hit host to come out to a prompt. Let's do an ls to see if it's in there, and sure enough it is. So I'm going to fire up gedit and open up employees.txt. So there it is right here. Nice. So you can spool off anything from Oracle using that. I figured you'd appreciate that tip. Alrighty, so back to SQL Developer and more about the select statement. Why don't we try some basic expressions? Let's run essentially the same query that we did before. Employee ID, first name, and by the way, you notice that I'm putting the columns on separate rows. You don't have to. I could do this if I wanted to. You see what I mean? So what did I do here? I'm just proving that it's a legibility issue. When Oracle parses your query, it just goes character by character and it ignores blank spaces. It's looking for legal characters. Legal separators between columns are commas, all right? And the statement terminator that tells Oracle where to stop processing is the semicolon. So in this case, we're grabbing 1, 2, 3, 4, 5 columns, 4 real columns. These exist in the base table, and I'm providing a virtual column here. Let's say I want to see double the employee's salary, see what that looks like. And I'm kind of letting the cat out of the bag. We haven't come to aliasing yet. We can use the as keyword to provide a column with an alternate name. And you can add aliases to existing columns or virtual columns. In fact, I'm going to add one to salary. I'll say instead of just having it come back with a column header of salary, I'll make this base sal, and then next to it we'll show double that salary as adjusted salary. Let's run the query, and there we have it. And you'll notice, sure enough, 2600 times 2 is 5200, and the columns are named at their default, what their original value is by default, but using as. As is actually optional, but I strongly recommend you use it so that your documentation, your scripts are really clear, and that anybody that reviews your code will know exactly what you're trying to do. Next, let's have a look at select distinct. Let's start with a select star from departments, see what that looks like. And I'm going to throw in yet another little bit. It's nice, I think you'll agree, I hope you'll agree as my student, that as we're learning the basics, I'm going to throw you periodically a little challenge by throwing you a keyword that we haven't formally discussed, but it'll give you a great head start as we continue through the training if you have some of these new concepts that are as yet undescribed rolling around in your mind. And what I'm going to show you here is order by. Order by allows us to do sorting. And again, the SQL Developer Code Complete comes up and says, now what do you want to sort by? Department ID, department name, location ID, or manager ID? I'm going to choose location ID in this case, end with a statement terminator, and you'll now notice that we have A to Z, an ascending sort by location ID. Now why did I do that? I wanted to show you all of the repetition that we have in this column. This is clearly a one-to-many relationship. We're looking at the many side of what must be IDs that exist in a location table. But you notice here how many departments are located in location ID 1700. You might have the question, well, what are the unique values for location ID? I see all that duplication, and you might be thinking, Tim, isn't this kind of Mickey Mouse? There's only 27 rows here. Yeah, that's fine in a small table, but as you get into data warehousing and large-scale enterprise deployments, you may have hundreds of thousands, if not millions of rows in a table. So select distinct becomes more important in that case. Therefore, we can type select distinct, name of the field, location ID, from the table. And again, we can order that if we want to. We can get rid of the statement terminator, do order by location ID. That's an ascending sort by default, and we see that in that table there actually exists only 7 location IDs. Now let me challenge you with a thought question. What if we wanted not only the location ID values but also the location names? What would we need to do there? The answer to that question, and congratulations if you got it correct, is to do a join between the location table and the departments table. I'm going to finish this demo by again showing you some really nice capabilities of SQL Developer. You'll notice on the left here in our connections tree, up till now we've just been creating connections. You'll remember that we can right-click the connections node to create a new connection, to do a disconnect, to import and export connection profiles. But once you've created a connection, you can expand that connection name and you'll see all sorts. These are all of the objects that exist in my ORCL sample database. And I want to draw your attention. We don't need to worry about all the rest of this at this point. I just want to draw your attention to the tables node. And you'll notice that it says filtered. Oracle is going to give you the tables, only those tables that you own by default. Of course, we're not going to be able to work with tables that we don't have privilege to. Now, if I log on as the sys super user and grant the HR account permissions on additional tables that exist in additional schemas, those will appear in this list. But Oracle, I think, has historically done an awesome job at completely hiding objects that you don't have permission to. It's not like you can see them and you can't do anything, kind of a look but don't touch situation. It's that those objects are literally invisible. It's really, really cool in my opinion. So check this out. You can expand these tables and it'll show you each of the column values. If you select the table on the right, this is the equivalent of the describe command, gives lots of information, including comments, which is a really nice way to document your table. It's harder to do that in SQL+. You can certainly add comments during your DDL statements there, but it's a lot easier to do that from within SQL Developer. I mean, just to show you really quickly, if you right-click the tables node, you can spawn a new table just by right-clicking and selecting New Table from the shortcut menu. You can add a primary key constraint. We can click Advanced to do foreign key constraints, any kind of constraint in point of fact, and just completely trick out your table. Really, really cool. Note that selecting a table gives you the description as we saw by default, but you can go across here and look at the raw data that exists in the table. You can get a report of all constraints that exist on that table, what permissions HR has on that particular table, statistics. I mean, it gets way beyond the scope of this course. But I've got to tell you, I'm really a big fan of SQL Developer. I can't believe that it's a free utility. Final thing I want to show you is SQL. This actually gives you the description of the object itself. It doesn't have to be a table, but this shows you the full setup of create table. I mean, isn't that wild? If I come back to my query builder, and let's say we want to work with select statement, you can drag and drop a table out into your worksheet, and you'll be prompted, what type of statement are you doing when you drag and drop? And by default, it's going to prompt you every time. If you're doing mostly select statements and you don't want to be prompted each time, you can deselect that and make sure that select is stored. You can change that under Tools Preferences if you later need to change that behavior. But notice that it gives you a nicely formatted select statement that grabs by default all the column names. And if you don't want a column name, simply select it and remove it. The select statement review. We began this nugget by understanding some basic vocabulary terms, principally the term schema. You now have a good understanding of how we use the word schema in Oracle Database. I also gave you a nice introduction to the HR sample schema that we're using throughout this course. Next, we performed a deep dive into the basic mechanics of the select statement. We understand its purpose, we understand its basic syntax and structure and usage, and I gave several examples in a practical context that you can practice on your own. We're going to be building upon this knowledge sequentially as we keep going. I hope you're as excited about that as I am. I hope that this has been informative for you, and I'd like to thank you for viewing.